Namaste everybody. So what we are starting today is on Kaushala Vardhanam. We are trying to actually do the Vardhanam. We are trying to give you more skills today, and the skill that we are going to focus on is agents, AI agents. We're hearing a lot about it, whether it's hype, whether there's reality to it, what is it. We'll have some time for Q&A also because I may not have thought about all the questions on your mind. Let's start with this. And Ganeshi, please let me know if there is anything that I'm missing on the chat. Anybody asks questions, and we can stop in between. I don't mind cutting the flow. So let's have some context. This is from the internet. I should have added the source, but this is what is machine learning. Let's first establish that. Machine learning is where you are using the data and the output. You don't know how to program it. If you know how to program it, if you know what is the if else condition, then no space or no need for ML. ML is needed only when the complexity of the algorithm or complexity of your loops and your business logic is so complicated, so unknown, but there is a hidden pattern, you don't know the pattern. That is when you go into the machine realm, machine learning realm. So, how do you think of it? If for traditional programming, you're all programmers here. You have data, your own data, and you have a program that you build. Given those two, the computer, the compilers, all your the tech stack produces an output. That's traditional programming. In machine learning, you give it the data and you give it the output. The machine learning generates the program. You don't even know what the program is sometimes. There is a lot of research going on to determine what is it that it generated. So it's that blind, and that is why all this anxiety, because sometimes we don't know what are the rules the algorithm has defined itself. So traditional engineering itself, like traditional, again, when I say machine learning traditional, that is the realm of XGBoosts and maybe early neural networks. So let's jump into that part now. When we started with machine learning, we had like simple classification tasks. Is it a dog? Is it a cat? How did it come to that? Now here in this case, is it a car? So you give it a lot of images, then you do the feature extraction. Like the data scientists typically, they would decide, okay, what is the one thing that determines, is there a headlight? Is there a door? Are there four wheels? What are the few features which determine that it's a car or not? This part again, from all the data, a data scientist would do or an ML engineer would do. Give it all these features, let the algorithm run. Again, you don't program the algorithm. You just tell it, this is the data, these are the features. And the output I want is it a car or not? Given all that, the output would be car or not. And then there was a mechanism called SHAP, which used to figure out what is it that decided ultimately. What was the feature that contributed to the fact that we decided it is a car. Okay, this is what machine learning was a few years ago. This still exists in some cases, you can continue to use. What largely started happening is the data set became so complex, so large, and so many features, sometimes unknown features, sometimes multiple data sets. All that came in that even deciding features was a challenge. How do you know what feature to pick? So that is when deep learning steps in. In deep learning, it's multi-layer neural network. So you just have multiple nodes. Every node takes in, like here, what a node represents is one feature. Okay, and in the case of car, the feature could be like from an image of 786 pixels, you have like first 10 pixels going here, second 10 here. So you can think of it that way. If you think of it as text data, you can think like column 1 here, column 2 here. That way you can think of just giving you a mental map. It's not that simple. So all those features go in, and then there is interconnections among them. What the neural network learns is what is the strength of this connection. How strong is every line going from one layer to another layer? It learns this based on the data that you provide. So after all this is done, which means you did not even specify which features, you don't know the features. You let the machine learning neural networks figure out what are the features that contribute to this output. That's the state of deep learning. So we know what is machine learning, when to use it. We now know what is deep learning. Now let's get into large language models. Why is it such a big deal? Anybody wants to take a stab on that? Because what happens is large language models and generative AI has become its own thing, and people forget that there is a continuity from machine learning happening here. Anybody wants to speak up? Usman, I see only you on camera, so bold. I appreciate that. If you want to take a stab, let me know. You can. You've heard on internet, I'm sure. Whatever you think it is.
Large language models is like ChatGPT and these different thing, and deep learning models is more of like the specific. I see here it says CNN, RNN. That looks like specific methods for specific deep learning. Um, I'm
Good.
having a hard time explaining it, but I think you understand what I mean.
Yes, yes, you're very close. I'm just going to peel the layers a little more from what you said. Yeah, you're right. What you said is correct. This large language model is also a neural network. It's a combination neural network. So when we have deep learning, there is one category, one kind of architecture that we set up. When it comes to large language models, the number of layers is too much, too many, and there are multiple steps. So that is what makes it a large language model. You have something called, when data is given, first thing you do is tokenize it, chunk it into smaller pieces. Then you create what is called embedding. So you may have heard of vectors in multiple places. What is a vector, right? Vector is basically converting that single token. Think of a token as a word that is converted into a vector, an array. And what that array contains, it contains some meaning to that word. For an example, if I have a vocabulary of 50,000 words, this is a typical example. Typical vocabularies that you get in the Meta Llama or any of these is 50,000 words. So in that space, you want to decide, like, for every word, there is a meaning associated. How do you determine the meaning? Like, is again, I'm coming up with some examples here. This may not be what it uses, it may be something else. If in a like multi-dimensional vector space, if there is say let's say India, there is a particular location like nation, maybe you want to have an array which indicates position, geography. Then you want to have probably another array where you indicate like population of the place, something like that. So every token that's created, it's represented through multiple positions, multiple arrays. So that kind of finally you get one vector embedding which conveys the meaning of that word. That is what you do from tokenizing to embedding. From there, there is a training layer that happens. So training is first level neural network. There are 6 such blocks typically in a transformer architecture. Then what ultimately happens from that whole 6 layers is it comes back with the probability of what the next token could be. You're still doing machine learning prediction. What are you predicting? Given these lines, which is probably a paragraph I wrote, what is the next word? So after you come get that next word gets added to your initial paragraph, and that next word generation keeps happening in a loop. Now, what neural networks have done is this has been tried before through RNNs, CNN specifically for images. This has been tried before. What has changed is the volume. Now, because there was a sequential generation, there was no parallel processing of every token. It was very cumbersome, and the length that it could hold was very small. I could only look back at certain number of tokens. Now, with transformers, some of these limitations have been dismantled, which has made it faster and parallelized. So now what happens is the entire paragraph that you're given, some processing on those happens in parallel. That's why you are able to increase the tokens that you can generate. Now, the next thing is after you generate those, the comparison that you would have to make from an earlier model is like you have only one next generation that used to happen. Now you have like an entire paragraph that you're able to generate. Where do you get that context from? That information is stored from in the tons and tons of data, which is probably internet web pages, all that is fed into those models. So that is the difference. You'll be getting data from multiple sources, probably the entire internet, and you have like long context windows, and you have like the main reason why this is so strong is when we initially had deep learning or even like ML, when we started, we had to do a lot of curation for every task I want to do, like fraud detection, for example, on my card transactions. I had to, oh, sorry about that. um, on every transaction that I had to do, I had to pick like what exactly my data set is, my use cases. Oh God. Give me 1 second. Able to mute this. Give me 1 second while I'm back. Meanwhile, any questions, anybody so far? Is it at the right level or are there more questions?
Yeah, feel free to type your questions if you don't want to speak up, or it'll be best if you make it interactive. So definitely encourage everyone to speak up.
Okay. Sorry about that. So let's continue with the discussion. Hopefully, I'll not get the call. I'll have to probably disconnect the WhatsApp. So to track, I tried to add it here because we had to post the link and then it stayed on. Uh, this is going away. My screen is kind of getting minimized. Okay, let's see if it happens again. For now, I'll just continue. I'm not able to open the window here. It'll distract the screen share also. So coming back to the point, why is this so important? Why is it game changing? Like we see the hype everywhere and everyone is like, oh, large language models are amazing. Two things that have changed. We had to curate the data before. Like if I want to build a fraud detection system myself, I have to generate the data that I'll have to tell these are all my card transactions. Of these are frauds. Use this to train your algorithm. Only then it can predict the next fraud. So much of curation, so much of processing had to be done before. Now, because these are general purpose models, because they have been trained and there are so many neural network layers already built into it, I can just say, here is my data and some examples. I can give it like hint it and let it choose. Of course, fraud detection is still best done the traditional way. Traditional in the sense prior to large language models way. I don't recommend using large language models when you already know because you're more accurate that way. But there are things that could not be done first with normal models, which can be done now. Second, not too much of training required anymore. No data set creation required anymore. So, most standard tasks and more dominantly natural language processing tasks, they have become highly possible, even with simple examples. So, what you see in ChatGPT is a transformer model. And that, think about it, for transformer to behave or respond to you, what did you have to give it? Just your question. And what is it doing? Based on your question, it is trying to predict and build the story of next tokens. It keeps doing that until it hits its limit of max tokens. Right? So that's why usage of models has become so easy that you don't have to build the story behind it. You don't have to build the pipelines behind it. That is the power of large language models. It has its own limitations, it has its own limits. People understand that. It's like just some of us might feel overwhelmed, like, okay, it can do anything. It has its own limits. It will not be able to do everything. Okay, and what happens? I'll not touch upon this category of machine learning, but I did hint where they sit, where they stand, like sit in the larger picture. Now, because our topic is agents, I'm not going to really spend time on the ML and deep ML part of it itself. But if there is interest, we can, I can give you resources, and two, if we want separate sessions just for that, we can do it. Let's go to agents because this is where your creativity lands. So I want to spend rest of the time talking about agents. Anybody wants to tell me what do you think is an agent? Rahul, Rahul, I believe, is Sony. Rahul Sony from Triple IT. I'm sure you have some context, so please jump in. I would love to hear where you are, so I am relevant to your to where you all are. Anybody wants to take a stab at it? What is an agent? Okay. So agent is at the heart of it the same large language models. Right now, most popular ones are transformer based. Those large language models, given some tools. Why tools? Because large language models are just predicting next token. You give it a simple math problem of 2 plus 2, it will say probably it is 4 based on some knowledge that it has ingested, some web pages that it has ingested. Do we really need that guess game for math? We know in math, we absolutely know what is the answer, and we also have tools that can do that calculation. We really don't need the ML part on this. So, what do we want? We want the agent to be able to use that tool. Don't stress your large language models, your multiple neural networks to arrive at a simple answer like 2 plus 2 is 4. We have tools, just invoke the tool. Invoke the tool, and whatever answer it gives, present it back. Okay, that is one context. Like this, there are many business applications. If you have, for example, your say meteorological department, you have weather data. There are tools that can get you weather based on calculations and based on whatever is like sensor data. There are tools already available. You don't have to ask the large language model what is the probability it is sunny today. It's going to give you junk. The biggest risk with large language models is it is by itself never going to tell you that it doesn't know. You have to train it to tell I don't know also. It will highly mislead you. It can say it is sunny when there is rain pouring. Okay, so that is another simple example. You'll see this weather and calculator in a lot of places. That's why I'm using these two. You don't want the model to predict it. You want the model to use a tool. Then what? You want the model to remember a few things. You don't want it to, sorry, not the model, the agent to remember a few things, because model is doing all the processing and predicting your next token, but it has already done some predictions based on what you have been conversing. You get this all off the bat today, which is why we don't recognize what is happening. It keeps track of your conversation you're having with it. Like, for example, even in chat gpt, you will see there is a history maintained. Over time, how the GPT responds to you will be different to how it responds to me, because there is a conversation history. So that is also baked in. When large language model is doing the prediction for next token, it takes into account all the prior discussion. All that goes to the model. It becomes the context for the model. Then based on that, it does the next prediction, which is why what you get is different from what I get when we search the same thing. Given these two, what you generally ask? You ask the model to hit a specific goal. Like you will tell the agent, suppose I have an agent that's powering my web page for a travel assistant. My goal will be make a reservation from, say, Los Angeles to New York. That's my goal. I I might give you further details, or I can just give you the goal. Then it's up to the agent to figure out what tools it has. Remember, agent is nothing but a large language model plus tools. It's going to figure out what do you want. It may have in its repertoire some tools available. The tools may require some inputs, right? So then it has LLM to its benefit and it has the tools. The LLM, which does the reasoning, which does the thinking to decide which tool to invoke, will come back saying, oh, you need to tell me which date, what time, which airlines maybe, right? Whatever your tools need, your tools are what your company has already built. If you're a travel agent a company, then you probably already have tools. Book flight. You may already have the API. Those things will be repurposed. It's not that this is building in silos. This technology builds on top of the existing business processes. So all these tools are your existing business processes. In an enterprise, there are tons and tons of these which have already been built. You tailor it to be able to work with a large language model. So, what is an agent? Coming back to the question, an agent is typically something which has ways which has a bunch of tools, which has a way to have some memory, which is given a specific goal, given all this, it has ways of taking some action. The action is either invoking the LLM or whatever the LLM gives you, working on that. And this operates in a given environment. Then there is a continuous looping. Okay, I took this action, what happened? I took this action, what is the result? That continuous looping that happens. So together, this is what an agentic system gives you a mechanism to have something which has an agency. Agency is what? It can take action on your behalf. Now, what can large language models do? They just tell you, they talk to you pretty much. They give you information. They don't do any action on your behalf. Like if you tell ChatGPT, send me an email, it will not do that, right? Because it doesn't have the tools. It will only tell you, this is what you have to do. You have to log in here, you have to put this, you have to do that, send, and then you have to send. That is the instruction you're going to get. It's not really sending you the email. But when you have an agent involved, it can do those actions on your behalf. Right? I would want to hear from the group here. What is the difference between an agent and a large language model? Anybody?
So large language model alone is just pattern recognition and language prediction. But an AI agent is the LLM reasoning plus planning plus acting plus adapting plus memory.
Okay, and most important,
Tool
tool.
plus tool. Yeah.
Plus tool. That's the most important part, because the tools are the ones that enable the agent to act on your behalf. So great points. Let's continue. What I'm presenting next is something that Amazon open sourced. So disclaimer, there are other tools too. I'm more aware of this, so I'm going to talk through this. Probably Google and Microsoft also have their own variations to this. I do like Strands because Strands was more recent and it has some capabilities built in which eliminates some grunt work for you. And I haven't, after some time, compared really to other frameworks. I've been using only this framework. So feel free to explore others also. This is agent development toolkit called Strands by Amazon. It's open source. You can install it on your laptops, you can run it. And the reason why I chose Strands is also because the examples and the code base is pretty small. It's very fast for you to get started. So what Strands gives you is again this agent, the model that you can choose. You can choose many models that you have access to. If you have a Gemini API key, you can plug in Gemini also. Even though the SDK is from Amazon, it does not block you from using any other model. You can use Bedrock models, which means if you have an AWS account, then just connecting to Bedrock will let you invoke all the models that you have enabled or you have approved access to. All those you can invoke from the agent. And the tools, again, there are a lot of built-in tools that come to you with Strands. We look shortly at the code base also. What this gives you is you don't have to explicitly plumb it and say, okay, here is my agent X, here is my agent Y. I want the chatbot to first invoke this, then based on results invoke this. We don't have to specify that. Why? Because large language models have evolved themselves. Initially, they were only doing the prediction. Now they have reasoning baked into it. Reasoning is like the model itself, the base model itself. These have improved a lot in just 2 years. So what they can do this reasoning themselves instead of outside workflow management. That was the case. When LLMs first came, this orchestration had to be managed externally. Now the models have become so superior that they themselves can do the reasoning. So you give it a goal, it will do its best shot to tell you what to do. If you tell it like this is my schema, these are my set of tools, the model is capable of doing reasoning based on your tool description and tell, okay, invoke this tool. Okay, that is a change. So with that, what happens is the code that you need, because this is what you create, the agent is what you build. This has become so simple as a starting point. Of course, the more complexity you want, you can always keep adding, but this has become very, very simple. And then tool definition also has become simple enough. Like give it a decorator and say, this is my tool, and it'll enable the tool. So now let's go into one code base code sharing that I want to do. And I'll drop links to this. Is it too small? Let me know if it's on my large terminal. So maybe it is coming out as a very small interface.
Yeah, this is good. This is
Okay.
readable.
And I'm going to put this in the chat here also. Okay, let's go to this. You can try this with me. If in your Visual Studio or any IDE of your choice, you do this install, this is going to get you that Strands SDK that I was talking about. And just these 3 lines from Strands import agent, and then this is the agent. So what it's doing by default, it is picking a model and no tools attached. It is just an agent right now. And when I run this with this command, it's going to create an agent for me. So now let me switch to my other screen as well. Let me stop sharing here and start sharing on the other one. My screen has changed its display and I'm not finding how to come back to this. Okay, I got it. Okay, now let me share this screen and I'm going to show you some code base. Again, while I set this up, I would love to hear questions and thoughts. Where are you? Are you finding this interesting enough? No, nothing?
Yeah, folks who are joining for the first time, this is a very democratic forum. So you're all welcome to speak your mind. So you don't have to only type. This is not a class session. So please feel free to come off mute and share your opinions or questions. There are no wrong questions or no simple questions. Anything and everything is welcome.
Yep.
Yeah, we
Are you
are
feeling
getting Sabahat is responding that she's finding it useful. So she has issues with her headset.
Oh, I have one question.
Sure.
Oh, okay. What's the difference between a model provider and a model?
Great
Because
question.
the default provider is Amazon Bedrock, but the default model is Cloud4 Sonnet. So what would
Right.
be the difference?
So Bedrock is like an API basically. Bedrock behind it has multiple models. When you invoke a Bedrock API, from there you're actually getting routed to model you have configured. For example, I think there are in this page only, oh, I'm back to the other one, right? I'll show you. So you look at my code here. This is a simple strands example with Olama agent. Okay, I'll start from the beginning and I'll show you what it means. So these are some install steps and the code repo that I shared has this example. So you don't have to worry about taking notes. Just start with this install. This is basically what this notebook builds. You have this agent here, the FileOps agent. It has given these 3 tools and you're interacting with this Olama server. Now, before I even jump to this, I'll start here, which is a simpler agent. It's a simple strands agent, and you're invoking Bedrock LLMs. So what are you invoking here? You're actually not specifying any model. You're just saying Bedrock is a model provider, but behind the scenes, it is set. Today, the default is Claude. It could change. So default Claude model is invoked. Now let's go into model providers here, and I'll show you, say, that is one thing that I have in mind already to show you. Let me open this. So here we are trying to open this model, okay, GPT-4 1.1 mini. So how do I set it up? Then I come to my model creation. Here I'm initializing my model, okay, and I'm specifying my model to use this, I'm specifying that model to be used by my agent. Okay, so here the agent model is Light LLM. It's saying Light LLM itself has been given these parameters. So what Bedrock does, this is not a Bedrock example, but this is directly going into Azure. Actually, let me also see if there is a Bedrock one itself. I mean, the one here is Bedrock only, but it is not showing you customizations. I'm trying to pick the one that has those tools. Maybe this, let's see. No. Bedrock model definition. It's not showing the customization. Let me find it in the web page. Okay, give me 1 second. I'll show you what it is. Bedrock streaming. Very good question, though. I like the way you're looking at it. And actually, let me do this. I'll show you on the screen how it looks. It'll make it easier for you to see this. So here, if you look at, this is my console. And if I go into Bedrock, you see I have this itself is Bedrock. Okay, this entire interface is Bedrock. Now, I have multiple models that I can access here. I can see them. Where is my model access? Model access page. You see, these are all the models I can invoke. So Bedrock as an API, when I say Bedrock as a model provider, it is this space enabled through you to you through an API. So you can invoke any of these. When you specify model ID equals any of these, you can invoke them from your agent. Did that answer your question, Jacob?
Yeah, I understand now.
Cool.
Thank you.
And yes, thank you. So this is the gap that I want to cover because information as such is available everywhere. I'm not going to add any value unless you ask me questions. So I appreciate that. Now I'll not go into the complex ones because you can keep exploring it as you keep learning this. So when you see strands invoking Bedrock LLMs, it's basically configured by default to invoke some model. You can tweak it. Like there is a way, if I say Bedrock model provider by default, Bedrock model config. I think I have one example somewhere else for this. Let me not give you wrong code. Maybe on this one. So here, this is again agent core. I'll show you next in the discussion. But okay, quick config. Now this, now this. So here if you see Bedrock model. So I'm creating another model and I'm changing my model name. So here I'm using Nova Micro. I'm setting this up to be used as the model and I'm giving it to the agent. So that is the configuration. If you don't configure it, by default, it has some model that it takes. Okay, coming to this, we have the agent created, we have a way to invoke, and with this, if I test, there is a joke it's giving. So what was the question? You are a helpful assistant. This is the system prompt and the user prompt, the one where you're invoking. So when you type in your chat GPT, this is essentially what the user message or query is. What are you saying? Tell me a joke. What it's saying? Why don't scientists trust atoms? Because they make up everything. It's a good one, right? I liked it. So anybody wants to suggest a prompt, we can try running it again. We can try something else.
So does it know Sanskrit? Can it tell a joke and translate in Sanskrit?
Let's try. I just want to be sure my tokens are valid. My bad with this. Okay, I probably have tokens valid. Okay, let me stop sharing for a minute. And I'll log in and be back.
So one day you will be saying, let me stop sharing a minute, and Zoom will automatically stop sharing.
Yes, that's true. That can happen. That is, in fact, very likely happening. I just haven't.
And then it will be a neurochip in your brain.
Oh, that is a little dangerous, but yeah, I do hear that as well happening. Okay, let me share this back. And now let's ask this question. I don't know what it's going to do. I have not tried this. Okay, let's see.
I have heard people using it to even
किमस्ति तत् यत् पीतं च पादैः च गच्छति. Kelam is the answer. Kelam, I don't understand. What is yellow that has 12 feet? Really? A dozen bananas. Okay, I don't know. Is it a joke? You feel free to laugh or don't laugh. I don't know.
No,
So,
but I have heard people have used enough models that not only does amazing Sanskrit, but even audio generates Sanskritam, which is very close, people are saying.
yeah, we
So,
have our demonstration available. So today when we do
yeah,
the
and it is growing by leaps and bounds. People are saying it is actually improving the moment we speak.
yes, yes, that's true. And the more people use it, the more it's going to get better. So, yes. This wasn't possible to this efficiency before. I have tried something like this, not exactly this prompt. It was mixing, like sometimes I have seen Arabic glyphs also. You say Sanskrit and it just puts everything multilingual. So it could not figure out the difference, but now it's gotten smarter. It's understanding this. So you can play with things. You can change the model here, optimize and see if it's how it's behaving to a certain prompt. All those trials you can do. Now, agent is just an LLM like a chatbot until you give it tools. Okay, remember that. Without tools, agent is no different than an LLM. It's just a wrapper on an LLM. So make sure you add a tool. If you're building something with agents, first thing, what are the tools that you want it to have? So now what I'm having here is a default built-in tool, again, calculator and weather that I was referring to. So when you give it this prompt and when you say, what is the weather like today? It automatically knows that if there is a question on weather, it has to use the weather tool. So you see here, it's saying tool 1 weather. And right now my tool itself does not have any logic. It's always going to give the same thing. Where is my tool? Oh, no, this is not my tool. I had a dummy function created. Here, yeah, this is the one. So this is like empty tool. I don't have any logic. But if I am an enterprise, I'll have enough content here created. I see Rakshit is
अरे ये एजेंट टूल्स चल रही है यार, लैंगचे नहीं है तो
Language design. So yeah, please feel free. That is exactly the feedback I'm looking for. So this is kind of LangChain, but it's a little less intense. In the sense with LangChain, you have to specify a lot more things. And here it is like simple tool, which like 3 lines and then your agent is ready. So if you are very comfortable with LangChain, you can continue using that. This is just one alternative and it gives you like details about what it did. And then there are ways to look at the logs. Here, if you run this, it's going to give you like with troubleshooting and debug logs. This is one technique where you can look at more content. So yeah, if this is, let's go keep looking at this more and more. There are now here the model is being changed. I had it right here. I didn't realize. So you are now changing the model to attach with a different LLM, changing the agent to attach with something else, and then it can now run. Okay, there are more things. We want it to search the internet now. So we are giving it additional tools again. There is a web search tool that is enabled. And now let's run this. Now, what is my question? You have a chatbot recipe. How does it behave? And I'm giving it the web search tool. When I invoke that, the recipe agent, it's going to show us this. So I can add any of these and then this is basically giving us based on these. By the way, look at the loops. It can do the same web search multiple times. One more search based on my results. I found several delicious recipes. Okay. So this is how it works. Now you saw that the agent has an LLM and the LLM reasoned that it has to do the web search multiple times to come to this recipe, right? So that is from Strand's part. Now I want to go next into the presentation itself. I'll go back to my other screen and we will talk about agent we created. So Rakshit, I would want to get your thoughts or anybody who has already played with LangChain. What is the next challenge? Once we have the agent ready, what do you do with it? Can you tell me what are the next steps? And the only reason I'm saying
like
Rakshit is
multiple lang chains together to
okay.
create a lang graph or multiple agents which can handle some tasks altogether.
Okay, fair enough. But then where would the agent run? You will do all those tasks, right? But then you want the agent to be, say, like not on your laptop, right? You do not, yeah, environment, exactly. Which environment? Where is that environment? Can somebody tell me their thoughts? So typically, where do cloud providers fit in is exactly there. You can build your agents on your laptop, and if it is a single user interface, you can keep using your laptops. But ultimately, the reason why cloud providers are relevant, any cloud provider for that matter, I just have because I know about AWS, I'm presenting this. Any cloud provider, why they're relevant is once you create the agent, you want to invoke the agent. run it, right? You don't want it running on your laptops. You want it available through an endpoint somewhere which you can share with others, which can scale, which is secured, which does not, kind of inadvertently change your file system, for example, right? We want that security. So before I jump into that environment, let's understand where everything fits. Okay, and then we'll go into the runtime for agents. So in AWS, we have these categories. I'm going to skip through this. Like Hero is, if you have not heard, it's an agentic IDE, very similar to Cursor probably. It has one additional feature of spec-based development, which means you can give it a goal. It'll create a requirements first, get your sign off on the requirements. Then it'll create a design doc, get your sign off, which you can auto approve if you want. You don't want it to ask, you don't. It will do without your information. And then the third one is when it actually goes to the task of implementing what you want. So that is one additional feature that I haven't seen yet on the other, what do you call, IDEs. So explore it. It's called Kiro. It was announced at New York Summit. I'm not going to touch upon these. These are all already created agents. I'm not going to touch upon this as well. We all already know models. We know Bedrock, and we have these capabilities where you customize, like add your data and create a fine-tuned model. That is what these capabilities are. Now with this, with these two, which you already know probably, if you log into your accounts, you'll already see this. With all this, you're creating an agent, right? But you want to run it somewhere. That running is what this new thing that was announced, new platform that was announced, Agent Core, gives you. What is Agent Core? It's actually a combination of multiple capabilities. There is something called runtime, there is a gateway, then there is memory. There are some additional convenience tools like it's called 1P tools. What that essentially means is a code interpreter and a browser. So you can bake these in, which means if you have like a web page and you want your agent to automate that entry into the web page, form filling, for example, you can use the browser tool here, and then that will do the data entry in a safe sandbox environment. It will not use your laptop. It's running in the cloud, right? And then there is identity. Now, why do we have to worry about identity? Because it's not just you. Sometimes the agent takes steps on your behalf. So we want to know which is that agent. Agent itself has become a first party citizen now. It has its own identity. So we can't keep thinking just like how we used to think before LLMs and before agents. Like the user who's invoking, not anymore. User plus agent is now a new identity, right? So those are the things. And observability, if you have done this before, then OTel metrics is what this provides you. Open telemetry, which means you can decide what kind of metrics you wanted to emit, so you can watch the logs. I'm not touching upon SageMaker today, but SageMaker, if it's of interest, we can have a separate deep dive session on this. What this gives you is ability to actually create a model of your own, which you can then put in here and then do the inference. Okay, I'm not touching upon this as well. This is like going into the semiconductors, the AI chips layer. So this is what we will look at next. Okay, and going into the capabilities. So hopefully this is new to everybody in the crowd, and this will give you some value. When you have an agent deployed on something called agent runtime, what this gives you ultimately is something similar to Lambda in a way. You can think of it as Lambda. So it will give you an environment to execute. What you need to supply it, you have to choose your own agent development kit. So LangGraph, LangChain also works. You can use strands, which we just looked at, and I'm biased towards strands just because the reduction in the size of code I got through strands. There was like 50 lines code that I had with LangGraph, which I was able to condense to 10 lines with strands. So it's still your choice. If you have like LangGraph, LangChain, which had been there before strands came, you can continue to use it. Creo AI also is a new, slightly newer than LangChain, but still predates strands. And there are other providers too. They have their own agent development kits. You can use whichever you want. What you really have to do is provide this instruction, which always that's what we do. Supply the tools. These two are pretty standard. Agent context, that's what you give it. And then you have like a runtime that you add, a decorator, and then you provided the identity configuration and you provided the observability configuration. You give all that and then you push that into your runtime. So your agent is now running on cloud. Then you have tools like Gateway. What Gateway does is it gives you an endpoint with which you can connect other tools. Like there are a lot of providers who give you open source MCP tools. You can bring those tools, attach it to an endpoint. Of course, you can directly call it within the runtime too. But attaching it to something like a gateway gives you that disconnect. It's not tightly coupled. You're kind of decoupling it. You can have one endpoint with which you can connect the same endpoint to another agent, and then it's able to repurpose. You're not configuring them at the same time. You have independence in how your tool space evolves and how your agent evolves. And the first party tools that we were discussing that you can invoke attached to your agent, you can make use of these tools. One is browser and another is code interpreter. And then there is identity that you attach. So by default, your IAM identity is assumed. If you want to have another identity, like if you have seen username, passwords that you're presented with, that's typically called an OAuth authentication flow. If you use Cognito, for example, Cognito has username password associated, which actually once you log in, it associates it to some IAM internally, and then you have some access provided. You have like user setup given to you. Based on that, you have availability or ability to access a certain agent. That's how identity works. And then you have observability here and memory. Memory is where you basically save all your conversations that's happening with this agent. It's not just the individual login, which means the user, it's also user and the agent response. Both are saved. And it's a separate namespace, which means if somebody else invokes the agent, there is a separate memory location for it. Separate memory record and basically a set of records that are stored together. This is how modern agent executions happen. So they don't run on your laptop. They have tools typically like these. You also have configuration to choose the model you want to use, which is powering your agent. You provide it all these details and you run it in cloud. It runs separately, safely, and it scales if there is more load, scales down if there is no load, which is cost effective and also safe for multiple users. So I have anything else? Okay. I think we're also up on time. The only thing I want.
Sunita ji, I was going to say maybe use a real example and map it to each of these boxes to say what happens if you're trying to act on an action. Let's say we want to do a very simple send an email. Today is our KV meeting, so we want to send a meeting reminder and we want it to do it automatically. So it has to look up a calendar, it has to invoke an email, it has to send it to the people on the group. So how would we do that with that architecture?
Perfect. So there are some use cases here. If you look at, let me paste this link also. I don't know if there is exactly the type of example that you were asking, but there are some really good examples. So I'm going to post this as well. Take a look at this. And the tutorials are really good. So let's take the example of maybe the one that you were going with. Market trends. You can tell me. Video games. Is everybody interested in video games? We can pick that. Or a customer support agent, whichever. Maybe I'll go with this. So customer support agent, I have not looked at exactly this repository, but there is a very similar structure to multiple of these. This has a credential provider. There is this runtime. So let's look at this, for example. Here we are defining what the runtime will look like. So you're giving it, say, you're here specifying agent core control, and you have an agent name that's given. This is the delete. Let's look at what other tools are there. Okay, these are the scripts. Let me see. Let's go to the README first. What is it that it's creating? It's saying that this is entirely running in AWS Cloud. And this is the runtime piece. There is a customer support agent. There are 3 tools that are given to it. One is retrieve, another is create calendar event, and then get calendar event. This and it's configured to invoke Bedrock LLMs. There is agent core memory associated to it. There is identity associated through OAuth. You can have multiple options here. You can also use, instead of OAuth, say IAM based. Then there is a gateway where you have these tools available already. You're not adding it to the current agent itself. It's already there. You are leveraging what's already there. They are available as lambdas. You're creating them as something that you can attach to your gateway endpoint. And you're using Cognito for your authentication. Now let's look at, like, this basically has all the details, how you should install, how you should set up. Okay, and so here it's saying, giving you a script to create an agent core gateway endpoint. If you run this command in your AWS accounts, it'll create a gateway endpoint. And then let's see where it goes. Let me look at notebook. This is all scripted. So this is good when you actually start building it. It's just not convenient to do a code walkthrough. Let me pick a, this is runtime. Let me pick something from a notebook, which will be easier to follow here because it's all going to be in one place. Let's look at strands. There is a lang chain and a screw example also. So if you see this, this is now that simple. This is only one part of what we were looking in the other one. A small part where we are deploying the agent in runtime, in cloud. So what this shows you is, this is just installation. We create a file, okay, and in the file, this, when you see, this does not have agent core yet. It is still just bare strands code that we had before. Okay, and then when you invoke it, it's going to create like just I might have this already executed with outputs, but you can try this. Just go to the runtime and play with the examples. Just click and go. It should work for you. If you have an AWS account, you will be able to continue. Till here, you don't even need AWS because this is running on your local. You can try it. The moment you attach runtime to it, you will need to have an AWS account with in Bedrock with access enabled to whichever model you put in here. Okay, so what are we doing here? If you notice the difference, we are attaching this. We are giving it an app. This is the app that you are going to invoke on your API invocations. So you give it this entry point, then you rest of this remains same. Like this part is same that was there before with strands. You're adding an entry point, something similar to what you would do with Lambda, and then you specify the app, which is like a Flask. I don't want to use these names because that's not exactly the technology behind, but just to give you a context mapping. Okay, oh, you will have some web page kind of a web user experience, and you specify the tools, the same tools that we saw before with strands. And then when you run it, it's going to deploy this. Well, this only creates the file, by the way, for now, because this is a write file command, magic line. What happens behind the scenes is this. You are using this app, it creates an HTTP server, listens on this port, all this. It's not ready yet, okay? Only the file is created at this time. What you continue doing is when you hit agent core configure, okay, it's going to create a Docker file. This Docker file will be visible in your own IDE actually. And this is what you do. You put it, give it a runtime, specify the name. This is the name that's going to show up in your agent core runtime. Then this is the file it's using as an entry point. And it picks the requirements.txt. Do we have it here? So here, if you see, it has, these are the libraries that will get installed. Pop question, where are these installed? Can anybody tell me? We have a requirements file, which will be used to install something somewhere. Where is the installation happening? Is it happening in your local?
Cloud instance?
Yes, it's happening in the cloud instance. When the agent is invoked, that Docker file will include installation of these requirements. So when you're running it here, locally, it would be running locally, you would install locally. But when it runs in cloud, this include the in here. It includes the installation of your requirements, and then this runtime will have your required dependencies installed, and then the endpoint will be made available to you. So here, if you see launch, it's going to show that deployment, and I might actually have a ready test for this. Let me see. Let me switch to my terminal, the other terminal. but we are up on time, so I want to be mindful. I mean, there is no end to this. We can keep exploring as much as we want, and we can go in any direction. I've already shared the resources. I want to pause here for a minute. One, was this useful? Two, do we want to go in this direction or do we want to pivot to something else? The purpose is to enable you with information so that when you start your next tests or next cohort that we start, you have this extra information and you can plan your use cases based on that. So I want to stop for a little and get those thoughts because I want to be mindful of the time also. Don't want to go on if somebody has to.
So thank you, Sunita ji, for taking the time to put all this together. I know we didn't have a big audience today, but we do have a engaged audience, hopefully. So yeah, let us know. I had sent out a list of other topics, but even this topic we only covered maybe scratch the surface. So there is enough things that we could be doing with this. And Sunita ji, with Sunita's lead, all of you can come with examples that we can actually try. So instead of going into more lecture mode, we can go into more like an interactive training mode. So we can say, those of you who want to play around with it, come with a use case and have Sunita ji give you, either mentorship or comment on how to do it better. And we can do an interactive session. So many possibilities, many ways we can take this. But obviously it is all for your benefit. We don't stand to gain much just by talking about it. So definitely put your thinking hats on, come with use cases, either through the cohort through the co-op that we are doing for this semester, or something independent that you want to try. I think as long as we have an engaged audience, any topic is fine.
By the way, if we stop recording, maybe there are a couple of points people may want.
Okay, thank you. Let me close the recording. Thank you, everyone.